Welcome, ladies and gentlemen. My name is David Cariello, and I'd like to welcome you again to our presentation of the first collaboration between Merck and Moravian College. We, the computer science senior class of 2014, have spent this semester working on OpenMRS and would like to present what we've done and what we've learned. To get the ball rolling, I'd like to welcome Nicholas Faraghi to shed some light on how this relationship came into being.
Thank you. So the genesis of this project began when two Moravian College computer science professors, Drs. Lang and Coleman, both attended a summer open source workshop on OpenMRS. Mr. Geet Lega, a 1984 graduate of Moravian College and a Merck employee, also expressed independent interest in utilizing OpenMRS within Merck. Together, this common interest led to the formation of a collaborative effort between Merck and Moravian College. Together, Merck assigned the Moravian computer science students, consisted of the second semester seniors, to task with a OpenMRS implementation, and the computer science students were able to capably implement this implementation. Knowing that we would use OpenMRS, our first task was to examine the technologies used.
As second semester seniors, one of our main objectives was to immerse ourselves in numerous technologies to be more readily prepared for a software development career. Our collaboration with Merck and OpenMRS allowed for us to do just that. When we initially began research on OpenMRS, we realized that there was a lot more to it than we had originally thought. It was almost overwhelming, some of us thinking that we were just going to be contributing to a Java project. But in addition to Java, we learned MySQL, Hibernate, Spring, HTML, and jQuery. On the presentation level, we used Dojo, which provided us a framework to render the data as we wanted. One of the most crucial points to these technologies was the OpenMRS API, which provided us with a framework to add, enhance, and utilize different reporting modules and other modules on the OpenMRS system. One aspect to OpenMRS that I believe to be also as crucial as the OpenMRS API is the community integration. With technologies such as Asana, GitHub, Jira, and IRC, we were able to stay connected with other OpenMRS developers and query them with questions and concerns on our own project. Though we didn't learn all these technologies at once, when we had a firm grasp of some of the technologies, we began working on tickets.
Completing these tickets was essential because it prepared us for working with the reporting module. The first thing our class had to learn was the process of completing these tickets. We were exposed to the management software Jira in order to identify and claim the tickets. Then we had to review our knowledge of GitHub in order to fork the repository. Then we became comfortable working with the new environment, which was Eclipse, to fix the tickets. And then finally we were exposed to submitting a pull request on GitHub. Our class wrestled with this new process while fixing the introductory tickets. We also struggled because of the miscommunication with the Amazon Cloud instance, but we were able to create our own instance on one of our lab machines. Even so, 3 tickets were completed. Our class of 10 broke up into subgroups and we each took one. One group fixed the issue involving uploading a new module, and the problem was that the tasks stopped working in the log, but they continued to work on the administration page. Another group corrected a control statement to default to null if gender is null rather than defaulting to female, which it did previously. And the group that I was a part of working with, we corrected a control statement to, the group that I was part of working with to create a locking mechanism so that for a patient identifier object. We also considered working on 4 other tickets, but we released them to the community so that they could complete them. With the tickets we learned also, we learned the new technologies in order to complete them. Even if it was just changing one line of code, we still utilized all of our new knowledge like Justin stated before. After learning the process and completing the introductory tickets, we felt we were prepared to take on the detailed project.
The original idea for this project was to utilize the Atlas module, which allows users to view open MRS implementations, the location, and the number of patients they have. We were tasked with adding additional functionality to OpenMRS that allows people to view disease prevalence throughout the world. When presented with this project, OpenMRS found two problems with this. One, there would be political barriers due to international privacy laws, and two, they believed this functionality already existed in the reporting module.
In response to the feedback from OpenMRS, the new goal of the project became to get information on diseases for the single local implementation or instance that is being used. The goal is for it to iterate over the local information and categorize it. The categories would be broad, encompassing many diseases, for example, respiratory or cardiac diseases. This would allow people at the instance to obtain meaningful information on locally prevalent diseases. This information allows workers at the site to identify what diseases they may want to target. The information will be shown in a similar format as the figure above to give a graphical, easy-to-read representation of data. As you can see, it is easy to look at the data and determine that for this site, there are more instances of cardiovascular disease than gastric disease. The revised project was shaped by the existence of the reporting module.
So we created our own instance of OpenMRS and used the reporting module to create a database. The module allows us to create our own queries. We can retrieve customized data based on certain parameters. As of now, we've only touched the surface of the queries that can be run against the data. We can create data set definitions that allow us to use parameters to obtain information from the data. So far, we've used parameters such as birthday, age, and gender. Now, you would think that our whole project could be completed using this module. However, this is not a direct solution to the task we are looking to accomplish, but the OpenMRS development team that worked and created this module foresaw that people would eventually want to ask questions to the data, and they would want to find specific information. So they designed the module in a way that allowed users to freely query the data. Now, this is exactly what we want to do, so this is a great starting point for our work. Since the reporting module has a good extensible design, we can create our own queries to query the data. While there are a few built-in ways to visualize the data, none of them are how we would like to see it. We do have the power and the capabilities of taking the data and rendering it in a manner that pleases us. The reporting module is a great tool, and it provides a great framework for us to accomplish the task we would like to achieve.
So to break down the project, we identified two main goals: to retrieve the data and to present that data in a human-friendly way. To achieve these goals, we first attempted to analyze the data flow model used in the reporting module. The process of constructing a report can essentially be summarized in three key steps: to retrieve the data per user specification, to interpret that data, structure it, and transport it to a renderer, and finally to render that information in a visually useful way. Identifying this was the case, we first began extending the reporting module framework by breaking up into two main teams: Team Iterate and Team Output. We were successful in constructing a query and in building a renderer. However, we faced challenges in the transportation stage. This will be discussed in more detail, beginning with Team Iterate.
As Jesse previously discussed, the reporting module allows us to add functionality easily. There are actually a few predefined existing dataset definitions, which allow users to specify what kind of data they want to put in their report. We looked through a few of these, but ultimately found out that we would need to add our own because they didn't have the functionality we needed. Luckily, OpenMRS and the reporting module provide tools and encourage this kind of development. Thus, we added our own dataset definition, diagnosis, prefix diagnosis. And there are two important parts, which you can see here: the dataset definition itself, which allows users to specify what kind of data they want and to filter that out, and then the evaluator, which takes this dataset definition and fetches data from the database and interprets that data based on the definition that the user specified. So altogether, these two classes were a little less than 100 lines of code each. And while Team Iterate was working on processing and fetching the data, Team Output was looking into how to meaningfully display that.
As it was mentioned before, the main goal was to display this diagnosis data in a user-friendly fashion. The reporting module already provides output files formats such as CVS and HTML. And we wanted to possibly look at third-party proprietary tools to display that, such as Gephi. However, we thought it would be more user-friendly to do this as a one-step process. So we began exploring open-source web-based toolkits such as Dojo and Chart.js. We settled on Dojo for several reasons. First off, its graphing tools provided the flexibility that we needed in order to display the diagnosis data in a variety of fashions. And secondly, it was already used in the OpenMRS project to display several widgets on the pages. In order to implement our own renderer using Dojo, there were a few challenges we had to overcome. First was to interpret the data that we would get through the transfer. We had to figure out how it would come to us and how we needed to structure it for Dojo to understand. Secondly, we had to apply the proper writer so that our HTML page would be sent to the proper location. And finally, we had to actually write the HTML to that file that would eventually be displayed to the user when the query is run. So what you see in this final image is a proof of concept displaying a graph showing a distribution of males and females in a single instance of OpenMRS. Because of the flexibility of Dojo and the reporting that we have established, this will be able to display the diagnosis data required by the project, and we will also be able to reformat this in a variety of different graphing formats. And that brings us up to speed to where the project is in its current form.
Our overarching goal was to create a more detailed graphical representation of the disease class burden data. However, as I'm sure you're well aware, we have yet to present that end result. We started the semester by tackling OpenMRS and understanding all the technologies behind it. We were able to create our own reporting module on a local system and retrieve some of our own data. From there, we broke off into two teams, Team Iterate and Team Output. Team Iterate used what we learned to get the data that we were looking for, and Team Renderer rendered that data graphically in an appropriate manner. What we're missing is a bit of refinement to bridge the gap between those two teams. And that's where the summer team comes in. Personally, our team feels that we'd be able to get this done within about a month, but due to the changing effect, might be a little different. But we are excited to pass this on to a very excited summer team. Thank you.